Here I'm going to teach you how to solve a rational inequality, meaning an inequality with rational expressions or fractions, using a sign chart. Okay, so let's get into an example right away. Solve. And the inequality we're going to solve first is x minus 1 squared times x plus 2 all over x minus 4 to the third power times x minus 6 to the fourth power. That entire fraction is less than 0. Okay? So if we're wanting to solve this inequality, we're wanting to find the x values that make it true. And so I'm going to do this using a number line sign chart. Okay? And luckily for us, this is already set up in a nice form. We've got one side factored and the other side 0. That's useful because if we can figure out where this fraction is positive, negative, and 0, then we can use all the x values where the fraction is negative to solve the problem, because we want to know where the fraction is less than 0. So that's what we're working toward. So with this guy factored, by the way, let's name the left side of this y. We're trying to figure out where is this y less than 0. Okay, we'll name the whole fraction y. So we'll set up a number line chart where we will list our x values, and above that we'll determine the y values for the x values on the number line, and then we'll go back and we'll figure out which x values give us y values that are negative. Okay? So here we go. We're going to cut our x-axis, our number line, at the zeros, which are positive 1, negative 2, positive 4, and 6. Okay, so the first one that we're going to write on the number line is negative 2, then positive 1, positive 4, and 6. And while we're at it, let's go ahead and list their multiplicities. Let's see, negative 2 has a multiplicity of 1, which is odd, of course. Positive 1 has a multiplicity of 2. 4 has a multiplicity of 3. And 6 has a multiplicity of 4. Those will come in handy later. Now, let's list the y values for each of these zeros, for each x value here. If x is negative 2, if I plug negative 2 into all the x values for the fraction, it's going to make my numerator 0. And you can check that out. And then 0 divided by a number is 0. So the y value I get when I plug negative 2 in for x is 0. If I plug 1 in for x, it makes my numerator 0 again. Same idea. If I plug 4 in for all of my x's, it makes my denominator 0, which you can't divide by 0, so that makes the output undefined. That makes y undefined. And if I plug in 6 for all my x values, it makes my denominator 0 again, which makes the whole fraction y undefined. Okay? Now what I want to do is get so I've got 0, 0, undefined, undefined. Now what I want to do is get what happens to my y values between each of those, okay? And I'm going to start by looking at the ends of my number line chart, and I can determine if y is positive or negative there. Well, first of all, I could just plug in an x value in those regions. That'd be simple enough. But using what we've learned in other videos about graphing rational functions, we could also use the leading term and the end behavior, okay? So the leading term is going to be a fraction. On top, if I multiply out everything on top, I'll get x squared times x to the first. That's x cubed. On bottom, I'll get x cubed times x to the fourth. that's x to the 7th. If I reduce that fraction, x cubed divided by x to the 7th, I get 1 over x to the 4th, which is an even power on the bottom. So my ends are going to shrink, but they're both going to be positive because of the even power. They're going to shrink because I'm dividing by x to the 4th. Nonetheless, the left end of my graph and the right end of my graph are both above the x-axis, so they both have positive y values. Okay, finally we fill in the 3 signs in between here in the middle using our multiplicities. 0 has an odd multiplicity. That means these signs have to be different. That means this has to be a minus. 1 has an even multiplicity. That means these signs have to be the same. So this has to be a minus. 4 has an odd multiplicity. These signs have to be different. So this has to be a plus. 6 has an even multiplicity. These signs have to be the same, and they are. So that's a good indication that we probably did okay there. Okay, now we've got a complete number line chart. And remember, what we're trying to determine is where is y less than 0. So let's go through and put check marks next to all the places where y is less than 0, meaning negative values. So here, y is positive. That's not less than 0. Y is 0 is not less than 0. Y is negative is less than 0. Y is 0, y is negative. Y is undefined, y is positive, y is undefined, y is positive. So the places where y is less than 0 are the 2 places where I have check marks. When I'm solving, I want to find the x values that make this true. So that means I have to look at the x values where I get this negative. That's all the x values between negative 2 and 1, not including negative 2 or 1. And then I get all the x values between between 1 and 4, not including 1 or 4. So those are the x values that give me negative y values. So the solution to the inequality, we might write in interval notation, negative 2 to 1, union 1 to 4. So all the x values in those 2 intervals make this inequality true. X values that aren't in those 2 intervals don't make that inequality true. Okay? Let's try another example. Our next example is to solve x squared plus x minus 1 over x plus 1 is greater than or equal to negative 1. Now what we need is 0 on one side. That's important. In the previous example, we already had 0 on the right side, so all we had to do is figure out where y was negative. That's why the pluses and minuses can be useful if the other side is 0. So we need 0 on one side and simplify the other side, meaning combine everything together into a single fraction. So if I want 0 on the right side, for example, I have to add 1. And if I add 1 on the right side, I have to add 1 on the left side. So that gives me my fraction plus 1 is greater than or equal to 0. Now what I need to do is I have to combine these with a common denominator. Because I've got a fraction, so I have to get a common denominator. And you should already know how to do this in many different cases. This is an intermediate algebra topic, not a college algebra topic typically. So I'll kind of go through this quickly. I'll recopy the first fraction, and I'll write 1 as a fraction. Well, that's 1 over 1. but I need the denominators to match. So I'm going to multiply 1 over 1 by x plus 1 over x plus 1. And what that does for us is, again, just copy the first fraction, multiply these together. 1 times x plus 1 is x plus 1. Same thing on bottom. And now my denominators match. So I can add my numerators together, which gives me x squared plus x is 2x. Negative 1 plus 1, those cancel to give me 0. So I just get x squared plus 2x on top, and that's all over the common denominator of x plus 1. Okay? So now the fractions are combined. I've got 0 on the other side. Now what can be useful if I want to find zeros and multiplicities is factor where I can. Okay? So factor. On top, what I can do is pull an x out, which leaves behind x plus 2. So now I finally have, so I took this guy and I factored it and I got that. Now I can begin my number line chart. So my x values that I'm going to cut are my zeros, which are 0, negative 2, and negative 1. So negative 2 comes first, negative 1, then 0 are my x values. Go ahead and write the multiplicities of each of those. They're all to the first power, so they all have multiplicities 1. We'll go ahead and find the y values for each of those x values. So if I plug negative 2 in, it makes my numerator 0, which makes the fraction 0. By the way, when I say y, what I mean is this whole fraction. So we'll call that whole thing y. We're trying to figure out where y is greater than or equal to 0. If I plug in negative 1 for x, it makes my denominator 0, so the fraction, or y, is undefined. If I plug in 0 for x, it makes my numerator 0, so y is 0. Then I need all the signs between. So I'll start with my ends again. So I need my leading term, which on top, if I multiply all that out, I'll get x squared for my leading term. And on bottom, I'll get x. X squared divided by x just reduces to x. That's not a fraction, so my end behavior is going to grow on both ends, not shrink. It's to an odd power of 1, so the right end is going to be positive and the left end is going to be negative. So the left end is negative, right end is positive, and then all my multiplicities are 1. That means all of these signs are going to be different. Because 1 is an odd number. So negative, this has to be positive, this has to be negative, this has to be positive. Now our number line chart's complete. We want to figure out where y is greater than or equal to 0. In other words, where y equals 0 or is positive. So it can't be negative, it can be 0, it can be positive, it can't be undefined, it can't be negative, it can be 0, and it can be positive. So the x values would be include negative 2, every number up to negative 1, don't include negative 1, start back at 0 and include it, and shade everything thereon. So the solution in interval notation is bracket negative 2 comma negative 1 parenthesis union bracket 0 comma infinity parenthesis. All of those x values, any x value in either of those two intervals, makes the original inequality a true statement. Okay, so you could check that out by plugging in some of the numbers from those intervals. It all comes down to making sure that you have a simplified fraction on one side that's factored where necessary, 0 on the other side, and then you can set up your number line chart with zeros, multiplicities, and end behavior. Okay?